as well as the input and output devices. So all these devices put together, we can define it as a computer system. We will coin Alan Turing. Sir Alan Turing has a father of computer science as well as the artificial intelligence which we are using in our day-to-day life now. Primarily, these are the blocks which are included in the CPU. That's the arithmetic and logic unit, control unit, as well as the primary memory. Hello everyone. So I welcome you all to this session. Over here, my name is Deepa Kutnikar and I'm an assistant professor working under Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysore. So yes, in today's session, we'll be starting the first chapter of first PUC Computer Science, that's Introduction to Computer Systems. So yes, my dear students, I would like to say one thing, like before watching this video, I just request to watch the one more video, that's the previous video, wherein we have discussed the complete syllabus of first PUC Computer Science. Also, we did discuss the question paper pattern as well as the chapter-wise blueprint. So it will be very helpful for you to understand the complete syllabus, wherein it is very similar to the overview of the subject. I can also say that the first video is a footprint. It is similar to the footprint of the subject, computer science. That's first PU computer science. Yeah. So with this note, let's start this session. So yeah, over there, the chapter number 1, Introduction to Computer Science. So yes, with respect to moving, like starting with computer science, as we all know, computers or computer science is a very, very good subject. And over here, it's application level subject. We can just go ahead and connect the things with each and every like practical things what we are using in our day-to-day life, right? So over here, during my session, I'll be sharing some amazing, fascinating facts for you regarding the computer or computer science subject. Yeah, isn't it great, right? Yeah, very good. So let's continue with our session. So that's chapter number 1, Introduction to Computer Science. And yes, over here, these are the topics covered. So yes, over here, these are the topics covered. So initially, we'll be discussing about the introduction to computer system, like what is a computer system and what is a computer. And then we'll be having a components of computer system. Yes, we know what is computer system. And next, how does a computer system forms? So what are the components included in it? So we'll be learning that. And next, we'll be learning the evolution of computer. Isn't it great? So that's the main thing we have to understand being a computer science student, like yes, how the computer, what we are using now is being derived, correct? So we'll be learning that under this evolution of computers. And then we'll be learning about computer memory types. And lastly, we'll also be discussing about the units of memory. So let me say you kids, yes, this is the chapter 1 video what we are recording now, but this is not a single video. We have this unit, that's chapter 1 for complete 17 marks of weightage. So yes, I believe you can understand the importance of this unit, right? So please pay attention and understand the things, okay? And I can assure you, you can easily score very good marks if you just go ahead and start reading from day 1. Yeah, with that note, let's start the session. So Introduction to Computer Science. All right, so before moving with computer science, let's completely understand what is a computer is, right? So over here, yes, we all have seen this, the model of a computer, correct? So now let's understand what is a computer. So how does it work? So what's the definition of this exact computer? So we can say a computer is an electronic device, okay? So it's an electronic device which can be programmed in order to accept input, yeah? So it will be accepting the input from our end, that's a user, and it will process that input as well as it will generate the results, that's nothing but an output. So altogether, we can say computer is an electronic device that can be programmed to accept data, process it, and generate the output. So this is a basic definition of computers. So as we already know, we have discussed the father of computer. It's none other than Charles Babbage. Yeah, all right, let's move forward. So with respect to computer, I have an amazing fact to be shared over here. The first fact over here is the modern computers, what we use in this digital era. Yeah. So the modern computers is capable of doing millions of operations per second, but still it follows the human's instructions. So that means no matter how powerful a computer is, how powerful a device is, it's just that our logic and creativity what brings or what makes that millions of operations being done in a second. Okay, so that's a first fact. Okay, yes, very good. Let's understand with the next thing, that's computer systems. Yes, exactly. As you can have a look, we have a complete computer system together. So yes, maybe you have got a simple idea what is a computer system called, correct? A computer along with additional hardware and software together is called a computer system. So as we can observe, we can use a computer, that's a hardware parts like keyboard, microphone, printer. Yeah, so all these are the hardware parts, and the thing which makes a computer work, that's inside that CPU board, which is inside this black box, which we call it as a software. So all put together, we call it as a computer system. So all hardware, software put together, we can define it as a computer system. And over here, I would like to share a thing, like by seeing this whole computer system, what we can define. So we can define a very amazing fact, that computer doesn't think. Okay, so it doesn't have the capability to think. It just follows the instructions what we have given to it. So that's the amazing fact, isn't it? All right, so let's move forward. Yeah, over there, yeah, we can also observe the internal parts like a SD card, a processor, which is utilized as a CPU for our computer system, isn't it? So let's understand what are the components or what are the devices which makes a computer system. Yeah. So over here, computer system primarily comprises of a CPU. Okay. It will be comprises of a CPU, a memory device, as well as a input and output devices. All right. So yes, let me repeat it. A computer systems primarily comprises of a CPU, that's a memory device, as well as the input and output devices. So all these devices put together, we can define it as a computer system. Clear? Very good. So let's go in depth now and understand what exactly is a computer system. Yeah, over here, we can observe the components of computer system. Yeah. So yes, over here, we can observe the components of a computer system. So it all starts with the input. So that's the input device. So what we give the input, it will be provided here. And then the input will be transferred into the control unit. So that's the control unit. Okay. So we have a CPU where we can say arithmetic logic unit, control unit, and a primary memory comprises of a simple CPU. And in some CPUs, we will be also having the secondary storage devices added to it. But primarily, these are the blocks which are included in the CPU. That's the arithmetic and logic unit, control unit, as well as the primary memory. And once we give the input, it will be provided into the CPU, yeah, where all the processing activities or the control activities are done. Also, we can say, or the arithmetic as well as the logical operations will be done inside the CPU, and then the output will be provided towards this output device. Yeah. So now we have to make a distinct, like what's this primary memory and the secondary storage devices. So any guesses, students? So yes, so whenever we give any input, so let's consider one example. Let's understand this with an example. So yes, we all use WhatsApp, isn't it? Let's consider we have to send a message for my friend. I have to send a message for my friend. Yeah, so I'll be typing the message. So while typing, I can see the message, correct? Let's consider I have to send a message like hello and good morning. Okay, let's consider this is my message. Okay, so I'll be typing this. So whenever I type this, you can also see that hello, whatever we have already typed, is also visible for us. So the thing what we have completed typing will be stored in our primary memory. Okay, so whatever the input we give, it will be initially stored in the primary memory and it will be sent forward to the control unit. Okay, where all the control related operations are done, and once if it needs any arithmetic or logical operation, it will be sent forward to the ALU logic block, wherein all the arithmetic or the operated related things will be done, and then the message will be sent. That's through output device. Okay, and in between this, if you want to store the message what I have to send today, okay, that's hello good morning, because yes, some friends are there like they'll be blaming us. Yes, you have not texted me, you have not messaged me, I'm the one who is always behind you. No, so we should have some proof with us, correct? So I'll be syncing my WhatsApp with Gmail, isn't it? So at that moment, what happens? The message whatever I have sent, yeah, so this will be sent to the storage device. That's a secondary storage device wherein we can store our message permanently. Okay, so that's a difference between primary memory and the secondary memory or secondary storage device. Clear? So these are the components, but let's move in depth and understand each and every block over here. Yeah, very good. Let's move forward. And yes, components of computer system, under this we'll be studying the first component. That's a very important one, which is CPU. Yes, please have a look. This is a processor. Yeah, so which is inbuilt on a semiconductor chip. Okay, so that's a CPU. So what's the importance of CPU? Yes, it is the electronic circuitry. Yeah, so CPU is the electronic circuitry of a computer that carries out the actual processing. Yeah, so it is commonly called as the processor, isn't it? We'll call it as a CPU or a central processor unit. So directly we can just call it as a processor as well. Clear? All right. So physically a CPU can be placed on one or more microchips. So physically we can place the CPU on one or more microchips, which we call it as an integrated circuit. Okay. So that's how the processors are being utilized for maximum utilization. So that's by placing a processor on one or more chips. So that's nothing but integrated circuit technology. Clear? Very good. Let's move forward and understand the next component. That's input device. So the devices through which the control signals are sent to the computer, we can term it as an input device. All right. So these devices convert input data. So how does it work? So these devices will be converting the input data into the digital form. That's either 0 or 1. So what's that? Yes, that's a digital form, which is nothing but either 0 or 1. So that's a digital form. Okay. So these devices convert input data into digital form that is acceptable by computer system. Yeah. So we can take an example like it might be a keyboard, a scanner, that's a barcode scanner, or a mouse. So all these are simple examples of input devices. Clear? So if we hear a keyboard, we have one interesting thing over here to share with you. So yes, that's a Braille keyboard. So any guesses like what is Braille keyboards? Yes, these are a special form of keyboards which helps the visually and impaired persons to use or type the letters, okay, to use the keyboards. So in this Braille keyboard, we'll be having the letters or the numbers on the keyboard in a dotted formats, okay. So let's consider I want to type A, okay, like if visual impaired person have to type A, then how can they assume? Like they'll be just feeling the dots and selecting that letter. So that's how this Braille keyboard is used, and it was the initial keyboard which was designed in order to help the visually impaired persons. Yeah, isn't it fascinating? The important fact with respect to the keyboard. Yeah, that's related to computer systems. So yes, data conversion we have already now. So input data will be converted into digital form. That's either 0 or 1. Yeah. Then comes a thing that's temporary storage. So as we have already learned something with respect to this temporary storage, that's whenever I input a data or a letter, it will be stored in the primary storage memory. That's nothing but temporary storage. Yeah. So wherein the message will be in the storage, wherein the message will be in the storage form until you complete that. So once you complete that, you'll get then effective input what you exactly need, correct? So at that time, you can shift that input to the secondary memory, but during you type, you want your message to be safe and secure, right? So that's the reason why we'll be using temporary storage along with these input devices. I hope it's clear to you what's a Braille keyboard and what's the usage of it. Yes, that's so fascinating, right? So it's used for visually impaired persons to help them, okay? And then the data conversions, yes, we did understood, like the input data, whatever we have provided, it will be converted. All right, then we have also understood the temporary storage. So these are the important points with respect to the input device. Yeah, all right, let's move forward. Over there, next is the output device. Yes, it's output device. So as you can have a look, these are a simple example of the output devices. Yeah, so monitor, yes, you'll be observing your output on the screen. So that's an example, a simple example of your output device, as well as the headphones, what we use in our day-to-day life is also an output device. Similarly, a projector, a printer, yeah, and the plotter. All these are simple examples of the output devices. Great, right? So let's understand what is this output device. So device that receives data from computer, yeah, for displaying or for physical production, etc. is called as an output device. So we can say that it converts digital information which is understood and processed inside the system. Yeah, so that digital information will be converted into human understandable form. That will be converted into human understandable form. That's the use of this output device. Isn't it great? So yes, we have an examples and number of ample of examples which are displayed over here. So that's the output component. So we are done with the components of a computer system. So can we remember that? So we have a input device, and next is a CPU, wherein we will be having ALU, CU, that's a control unit, and the primary memory, or we can call it as temporary memory in order to store the data for temporary time being. Then we have secondary storage, wherein we can go ahead and store our data for permanent. Then once the data are processed, we'll be sending it towards the output device. So that's the simple components of a computer system. So I believe these things are clear to you, right? All right, students, let's move forward with evolution of computer. Yeah. So yes, that's evolution of computer, or we can also say timeline of computing devices. Isn't it great? So yes, initially this evolution did started with that's on 500 BC, like 3000 years before from now, by abacus, by inventing an abacus. So it's a complete computing device, yeah. So wherein abacus supported us to do the simple arithmetic calculations. Is it clear to you? All right. So next we are having this Pascaline. So yes, Pascaline was invented by Blaise Pascal. Okay, so it's a type of mechanical calculator, yeah, wherein it was invented purely to do the addition and subtraction of two digits, yeah. And moreover, this Pascaline was also capable of doing multiplication and division, but the method used in order to do that multiplication and division was and repeated addition and subtraction method. So that's with respect to Pascaline. Isn't it great? And up next in the year 1834, that's the year where the invention of our computer happened. Yeah, the basis for the invention of computer started in this year 1834 because it started with an invention of an analytic engine. So Charles Babbage, who is called as the father of computer, correct? So they invented an analytical engine, which is also a mechanical computing device, which was designed for inputting, processing, storing, and then outputting the information. Yeah, so that's the basic definition of our computer, correct? So it will accept input, it will process the data, it will store, and it will be forwarded to the output device. So that's the basis for the invention of the computer what we are using in this digital era. All right, so that's at the year 1834. Clear? Yeah. So let's moving forward. In 1890, we got tabulating machine invented by Hermann Hollerith. So he designed a tabulating machine. Yeah, the tabulating machine was invented by Hermann Hollerith, wherein he designed a tabulating machine which was capable of summarizing the data stored on the punch cards. Yeah. So stored on the punch cards, it is considered to be the first step towards programming. So please note, students, it was the first step towards programming and the first step towards the creation of computer. That's the basis of computers started in the era of 1834, and in 1890, it started the first step towards programming. Yeah. So over here, up next is at 1937, we got invention of Turing machines. Yeah, so the Turing machine. Okay, so yes, in the year 1837 we got the invention of Turing machine. Yeah, so wherein we can see Turing machine concept was generally purpose programmable machine which was capable of solving any program by executing. Yeah, so this Turing machine was capable of executing any complex program. Yeah, how was that capable? By programming the things, by programming the information which is stored on the punch card. So yes, that's punching cards. So let's understand what is punching cards, right? So punching card is nothing but a rectangle piece of cardboard where the data is stored in the form of punching holes. Yeah, so that's the punching cards. And you remember who's the father of computer science? Yeah, so that's the one who has invented the Turing machine. That's nothing but Alan Turing. So we will coin Alan Turing. Sir Alan Turing has a father of computer science as well as the artificial intelligence which we are using in our day-to-day life now. Okay. So yes, up next, it's 1945. Yeah, so over there at the year 1945, we had person named John von Neumann. Yeah, he introduced the concept of stored program computer, which was capable of storing data as well as the programs on the memory. So over there, initially I told like I'll be sharing some amazing facts, right? So the amazing fact with respect to evolution of computer is nothing but the first ever electronic digital computer which was designed. So can you guess the size of that? So that was as huge as it took the space of complete one room. It was so big. The first electronic digital computer was that big. Isn't it great? So that device is called as ENIAC, which is nothing but electronic numeric integrator and computer. Yeah, electronic, numeric, integrator and computer. And the EDVAC is the followed architecture of ENIAC, which is also developed based on the same concept. Great, right? So up next in 1947, yes, exactly. So we got the vacuum tubes. So yes, in 1947, we got the invention of transistor. So you don't believe how the transistor has changed our lives, okay? So only because of this transistor, our lives are becoming so easy. It's because the devices are becoming compact. It's just because of utilization of this transistors, okay? So yeah, vacuum tubes were replaced by transistors, which was developed by Bell Labs. So how is a transistor developed? It's by using the semiconductor materials. All right. So next, let's move with 1970, wherein we got an invention of integrated circuit. So let me tell you, integrated circuit is a thing. Yeah, it's a circuit wherein we can integrate one or more number of circuits all together in order to make the device compact, and at the same time we'll get the exact efficiency of the same. Like if example, let's consider we'll be working on the 3 simple boards, okay, or the simple circuit boards, and if I want to reduce the space, okay, so then I can think of integrating all 3 at the same time by using that semiconductor materials. So this integrated circuit paved the way for us, wherein we can say it has a silicon chip which contains electron-electric circuitry. So that's a silicon chip which contains complete electronic circuitry in a very small area, okay? So the size of computer drastically reduced. So yes, we can say the size of computer was drastically reduced because of this invention of integrated circuits. That's in 1970. So this is how the evolution of computer followed. All right. So yes, we did started the evolution of computer from a basic device, that's abacus. Next, we used a calculator, that was a mechanical calculator. Then from mechanical calculators to modern PCs. Yes, we have moved from calculators to the PCs, isn't it? So yeah, over here we have to mention one thing, that's a Moore's law. So yes, Moore's law states that it predicts like the transistors on the boards will be doubled for 2 years. Yeah, the number of transistors will be doubled for every 2 years. So that's a prediction through Moore's law, okay? So now let's move forward and understand what's microprocessor. So yes, microprocessor is nothing but CPU on a single chip. Yeah, so that's nothing but we can define in a single word like a CPU on a single chip. Then we have different generations with respect to the microprocessors. That's initially we have LSI, but we did started with simple integrated circuit, but along with the advancements, it moved towards LSI, that's large scale integration. Then we have VLSI, which says like, yes, it's a very large scale integration. All right. So then SLSI, which says like super large scale integration, and that's with the increasing power. Not only the space is reduced, but the power is also maximized. So that's a beauty of this computers, okay? So that's the beauty of electronics. So over here you can just have a look the transition. So we were using a simple vacuum tubes, then we moved on with the transistor, then we came with the integrated circuits, isn't it? Then we moved with the VLSI technology, and now we are with a tech of robotics. Isn't it great? So yeah, let's move forward. And over here, so this is evolution of computer, which is what, like this is a complete summary, like in which year, what event or what device was introduced. With respect to the evolution of computer, yes, let's revise. Like in a year 500 BC, we did got invented a device, abacus, right? So which was a complete mechanical arithmetic device. So which is used for complete arithmetic operations. Then in 1642, we got Pascal invented, which is a mechanical calculator. Then at 1834, we got that analytic engine coined. So which is nothing but which formed the basis for our real-time computer, what we are using today. Then in 1890, we got tabulating machines where we got the use of punch cards, and over there the era started of programming. So over there started the era of programming. Then we got in 1945 the ENIAC machine, which was the first electronic digital computer which was as big as a room. Okay. Then we were in 1947, we got transistors. Because of invention of transistors, the technology just got boomed. Then in 1970, that's integrated circuit. So this is a complete evolution of computer systems, right? So yeah, great. Let's move forward and understand the computer memory types. All right. So yes, look, it's so colorful. So over here we are having RAM, and this is a ROM, the cache memory, and the secondary memory. That's a pen drive or DVD. So these are the examples of secondary memory. Yes, don't worry, we'll be learning this in depth now. Okay. All right. So now let's start with primary memory. So yes, as we know, primary memory is a thing where program and data are loaded, correct, into the primary memory before processing, isn't it? Before it is shifted towards the CPU, the raw data, whatever we type, it will be initially stored in this primary memory. So in order to store that, we have two types of primary memory. That's a RAM as well as ROM. Okay. So RAM means random access memory. Okay. And ROM, it means read-only memory. So that's two types of primary memories. So what's this RAM? Let's understand that. So yes, it's a volatile memory and it's a temporary storage device. Okay. So yeah, over there we can say the next one, ROM, has non-volatile memory and it retains the data even when power is off. So it retains the data even when power is off. So yes, let's understand what is this RAM. So RAM, it, like whenever we will be typing our information, at that time the information will be stored primarily in this RAM. Okay. So as long as the system is on, at that time the data will be in the RAM. Okay. But once the power is off, or in case in between if the power is shut down, so at that moment all the data what we have entered will be wiped off. Okay. So for that reason we call RAM as a volatile memory. Yeah. And next is a ROM. So ROM, read-only memory. Over here we can the data whatever we input will be transferred into ROM. Yeah. So why is it transferred? Because if we are using some useful information or the high level application level programs, at that time our data will be directly into the ROM. Okay. So wherein we call it as a non-volatile memory. Why? Because whenever we type the data and at that moment if the power is off or if the power is shut, even at that time we can retrieve our data whatever we have entered. So that's the reason why we call this ROM as a non-volatile memory. Great, right? So yes, it retains the data even when power is off. So this is with respect to primary memory. Now let's move forward with the cache memory. Yeah. So cache, we call it as a high speed memory between CPU and the RAM. So yes, the cache memory, it stores the copies of data which are used frequently, thus reducing the time required for retrieving the message from the primary memory. So we can call the cache memory as a high speed memory. Okay, because it will be having a copy of data which is already been stored in the primary memory. So that's the reason why we call it as a high speed memory. So yes, then let's move forward with the secondary memory. So as we know something about secondary memory, correct? We have already discussed it. So secondary memory is used for permanent storage. So yes, secondary memory is used for permanent storage of the data. So we have an examples of secondary memory like a hard disk, CDs, DVDs and all. So that's a hard disk or a CD or DVD and all. So this is a memory, that's the memory types of computer. Clear? So a primary memory, a secondary memory and a cache memory. Great. All right, very good. Let's understand the units of memory. So as we all know, the computer just understands zeros and ones. That's a binary digits, okay? So what are binary digits? That's a 0 and 1. So we call either 0 or 1 has a bit, okay? So let's understand it. So yes, a bit is either 0 or 1, okay? Then let's move forward. What if we have a 4 bits together? That's either 4 number of consecutive 0, 1, 0, 1. So in this way, if we are having 4 bits together, so we can call it as one nibble, okay? One nibble. Yes, that's a one nibble. And if we are having complete 8 bits together, so yes, for 8 bits, we'll be calling it as a 1 byte. Yes, I hope it's clear to you. So that's the unit of memory, which we call a nibble, which is nothing but 4 bit, and a 8 bit is called as a byte. Okay, so now if we are having more than number of bytes or more number of zeros and ones, we can't call it, right? So we are having the units for that. So the first one is the kilobyte. So what's kilobyte? So kilobyte is nothing but 1024 bytes. Okay. So what about bytes? We already know that 1 byte is equal to 8 bits, correct? So similarly, 1024 bytes, we call it as 1 kilobyte. All right. So next, moving forward, MB, which is nothing but megabyte. So 1024 kilobyte, we call it as 1 MB, correct? And let's move forward and understand the GB. Yes, we use the pen drive, correct? That's capacity will be termed or will be defined in terms of GB. Yeah. So over there, we call 1024 MB as 1 GB. And similarly, we call 1024 GB as 1 terabyte. Tera, TB is nothing but terabyte. Next, PB, it's petabytes. Next, it's EB. So 1024 PB is nothing but 1 EB. That's exabyte. Exabyte. Then we are having 1024 EB is nothing but 1 zettabyte. So that's ZETTA, zettabyte. And 1024 ZB is termed as 1 YB, which is Y stands for yotta. YOTTA. So that's 1 yottabyte is equal to 1024 ZB, that's zettabyte. So this is a terms of memory, that's a unit of memory where we can define the devices. Correct, right? So we are using the pen drive. So what's the capacity of the pen drive? So we'll be saying that in terms of kilobytes, okay? So that units of memory will be initially using the pen drive with a GB, okay, GB unit. So that's the thing which is used in this era, okay? So even we have updated one like a terabyte pen drives and all, but it's a bit costlier. So this is the units of memory. Yeah, thank you. So this was for today's session. So let's continue the other topics in our upcoming sessions. Yeah, I just request you to have a look and start studying from day one so that it will be helpful for you. Yeah, thank you.